Now, crystal field splitting in tetrahedral and square planar complexes. So we have done tetrahedral and octahedral complexes. Today we will do tetragonal and square planar complexes. So this is the splitting for octahedral complex, and in case of tetragonal complexes, what happens? The energy of dx square minus y square, it further increases, while the energy of dz square, it decreases, and energy of dxy increases and energy of dxz and dyz decreases. And in case of square planar complexes, the energy of dx square minus y, again it will further increase, the energy of dxy will also increase as compared to what it is in octahedral and tetragonal complex, while the energy of dxz yz, that will decrease as compared to that of a tetragonal complex, and that of dz square, it will further decrease. Now what is the reason behind this? Now, the splitting of d orbitals in tetragonal and square planar complexes, it can be understood by what if we assume that from an octahedral complex we move two ligands which are lying along, if we move two ligands which are lying along z axis away from an octahedral complex. I'll repeat कि अगर दो ligands जो z axis के across lie कर रहे हैं, if we move them away from an octahedral complex, then what will happen? As the ligands lying on the z-axis are moved away, the ligands in xy plane experience greater repulsion from the electrons of the ligands in tetragonal complex than in octahedral complex. What will happen if you move the ligands which lie across the z-axis away? तो जो ligands जो हैं which lie जो एक्स वाई प्लेन में लाई करते हैं, वो जो इलेक्ट्रॉन्स हैं एक्स वाई ऑर्बिटल्स में, डी एक्स वाई ऑर्बिटल में या डी एक्स स्क्वायर माइनस वाई एक्स माइनस वाई स्क्वायर ऑर्बिटल्स में जो इलेक्ट्रॉन्स हैं, उनको वो ज्यादा रिपेल करेंगे अगर हम इसकी कंपैरिजन करें ऑक्टाहेड्रल कॉम्प्लेक्स से. देयरफॉर the energy of d orbitals in xy plane increases. I have shown you in the diagram in the previous page that their energy, it will increase, and hence the energy of dx square minus y square and dxy orbitals in tetragonal complexes, that will increase as compared to the energy in the octahedral complexes. And as far as the question of square planar complexes is concerned, now if we move away the trans ligands which lie across z-axis, or if we drop them out completely, if we totally remove them, then what will happen? A square complex of ML4 type, a simple square planar complex, that will be formed from an octahedral complex. Now this will be accompanied by further rise in energies of dx square minus y square and dxy orbitals, because z एक्सिस के अक्रॉस तो लिगेंड्स हैं ही नहीं, दोज वी हैव ड्रॉप्ड आउट, तो वहां पे रिपल्शंस नहीं होंगी, तो z जो ऑर्बिटल्स हैं उनकी जो इलेक्ट्रॉन्स z ऑर्बिटल में लाई कर रहे हैं, जैसे डी एक्स जेड स्क्वायर में जो लाई कर रहा है, उसकी एनर्जी डिक्रीज होगी. डी एक्स जेड एंड वाई जेड में जो इलेक्ट्रॉन्स लाई कर रहे हैं, देयर एनर्जी दैट विल आल्सो डिक्रीज, while the energy of orbitals in while the energy of the electrons in orbitals dx square minus y square and dxy, that will increase, वो बढ़ेगी. Now what are the factors which affect the magnitude of crystal field splitting? किस पे डिपेंड करता है आपका मैग्नीट्यूड crystal field splitting का? First is the nature of the ligands. What kind of ligands do we have? Now it depends upon nature of ligands. The greater the ease with which ligands are with which the ligands can approach the central ion, the greater is the crystal field splitting caused by. अब जितनी आसानी से आपका ligand central metal ion के d ऑर्बिटल्स को, जिसमें इलेक्ट्रॉन लाई करते हैं, उनको अप्रोच कर पाएगा, उतना ही आसानी से स्प्लिटिंग वो कॉज कर पाएगा. So and there is a series which tells us about the various ligands and with which is they, and what is the extent of splitting which they cause. And this series, there is a series which is called as Spectrochemical Series, in which the ligands are arranged in the order in which they produce increasing values of delta with a particular metal ion. How so we can see that this is the you have to remember that this is the increasing order. So iodide, you can see that is less than bromide, less than chloride, less than fluoride, which is less than oxalate. Oxalate and water are almost same, which is less than pyridine. Pyridine and ammonia are almost same, which is less than ethylene, which is less than NO2 negative, which is less than CN negative, which is further less than CO. So you can see, we can see that maximum the ligands which cause small crystal field splitting, like iodide and bromide, they are called as weak field ligands, while those ligands which produce large delta crystal field splitting energy, like CO, carbonyl and cyanide जो है ligand, are called strong field ligands. Then oxidation state of the metal ion is another factor. The oxidation state of metal ion influences the magnitude of crystal field splitting. Now it leads to the crystal field splitting. It influences the magnitude of crystal field splitting. The metal ion with higher oxidation state causes larger crystal field splitting as compared to the one with lower oxidation state. तो जितनी ज़्यादा आपके मेटल पे चार्ज होगा, जितनी हाई उसकी ऑक्सीडेशन स्टेट होगी, उतना ज़्यादा वो क्रिस्टल फील्ड स्प्लिटिंग कॉज करेगा एज कंपेयर टू दैट मेटल आयन विच हैज लेस ऑक्सीडेशन स्टेट. Then next reason is size of d orbitals or transition series. Now the extent of crystal field splitting increases by 30 to 50% as we move from 3D series. 3D series is first transition series to 4D series, and 4D series is the second transition series, and from 4D, that is from second transition series, to 5D series, that is third transition series, the increase is same. See, as the transition state from splitting caused by first transition state is less, then it is caused by second transition state, and third transition state की जो metals हैं, in them the splitting is maximum. This is because, and the reason behind this is that 4D orbitals are bigger in as compared to 3D orbitals, obviously, and the former extend farther in space, and they have extend larger in, they have, since 4D orbitals are bigger in size as compared to 3D orbitals, so they extend more in space, and as a result the electron in 4D orbitals, it can interact more strongly with the electrons in the ligand orbitals. So interaction between the electron of d orbitals in case of 4D and 5D orbitals is more as compared to that of 3D orbitals, and hence crystal field splitting is more. So obviously the reason is the interaction, जितनी बड़ी transition series है, जैसे थर्ड ट्रांजिशन सीरीज में ज्यादा इंट्रैक्शन है डी इलेक्ट्रॉन्स और लिगेंड्स के बीच, तो स्प्लिटिंग ज्यादा है. 4D में कम है उससे, और 3D में फर्दर लेस है. देन ज्योमेट्री ऑफ द कॉम्प्लेक्स. The crystal field splitting energy of tetrahedral complex is nearly half the value of octahedral complex. This we have done. Delta T is -4/9 of delta O. As a result, the splitting energy for tetrahedral complex is less as compared to pairing energy, and tetrahedral complex are therefore high spin complexes. So splitting जो crystal field splitting energy है वो tetra, वो that also depends upon the geometry. जैसे tetrahedral complexes में it is less as compared to in octahedral complexes. So these are the reasons. Thank you.